So in chapters 8 and 9, your hypothesis tests are going to center around either mu for a population mean, sigma for a population standard deviation, and p for a population proportion. You're going to have to decide, is it one population or two populations? And that's going to help you decide what kind of test that you're going to do. So in our first example here, going to one of the old exams online, you had a random sample of males, another random sample of females, talking about if they're right with their left or right hand. So you've got two samples, so that puts you in chapter 9 kind of thing. And then you're talking about the proportion of people who are right or left-handed. And you want to know, are those proportions equal? So does the proportion of, or the rate of male left-handedness equal the rate of female left-handedness across these populations? So if you're filling in H0, it's going to be proportion of left-handedness for men equals the proportion of left-handedness for women. And the alternative is that they're not equal. You know, you can use, if you wanted to write 1 and 2, that's fine as well. The thing with 1 and 2 is that you'd have to tell me which one's which. So you'd have to write down, for instance, P1 is a proportion of men who are left-handed. Now, I don't know what President Trump was, but before President Trump, 5 out of the previous 6 presidents were left-handed, which is statistically improbable because there's a lot more right-handed people than left-handed people. So maybe that's saying something about you lefties. So, okay. So are we good with this conclusion, though? I mean, you can write it either way, is my answer. But if you can write it like this, you know, you have to tell me what the P1 represents. I mean, sometimes it'll be obvious. That's okay. Let's try another one. Let me scroll down to, say, let's do this one. Now, they're not always going to come right out and tell you what parameter you're testing. You kind of got to use your intuition to figure things out. So it says, in a data set in the book, you'll find the weights in pounds for cola for a sample of cans of regular Coke and for a sample of cans of Diet Coke. Use a 1% significance level test to claim that the average weight of these cans is the same for both types of Coke. First of all, one population or two populations? Two populations. Secondly, you got to decide what parameter you're testing. So let me kind of zoom in a little bit here. And there. So it's two populations. Are we testing proportions? Are we testing standard deviations? So you're testing means, and there's two variations on testing means. It could be they're independent samples or they're matched pairs. So do you think somebody went through and lined these up and says, okay, at the same time we'll take one can off the regular Coke line and one can off the Diet Coke line? Or are they just random cans? What would you expect? Probably just random cans. I don't think they're really matched in any particular way. So this would be the independent case. So if this was your problem on a test, then you choose this one. E would be the correct answer there. And as far as the rest of it is concerned, what parameter reflects population mean? So Diet Coke and mu sub regular Coke, Diet and regular. And then E. All right. Let's keep going. Um, sorry, can't seem to find the right page. Listed below are the heights of mothers and their daughters from a journal kept by Sir Francis Galton. At the 5% significance level, test the claim that there's no difference in the heights of mothers and their daughters. So, okay. How many samples are we dealing with? One or two? Two samples. What parameter are we going to test? All right, well, let's see. Someone else want to weigh in on that? I got some of the people in the chat. HO and HA. Well, you've got three parameters that you have to choose between. Mu, sigma, and P. Are women's heights do they have anything to do with proportion? No, so we can nix that one. Was there any talk about standard deviation or variability in this problem? No, so we nix that one. So it comes down to mu, which makes sense. You would talk about the average height of a mother versus her daughter. So, all right. So it's going to be a claim about averages. Let's take a look back here. Test a claim that there's no difference. Now, if there's no difference, what's H naught going to be? They both have to be equal. The mother's height has to equal the daughter's height. And then the alternative is that they're not equal. The last question you got to ask is, how do we want to test this claim? There was two ways to test the claim of no difference in the heights of women, or that is, two population means being equal. Is it a dependent case or an independent case? Caitlin, what do you think? Dependent? Caitlin, do you agree with Caitlin? All right, good deal. Yeah, they're dependent. Mothers and daughters, I mean, height is certainly a genetic trait. There's definitely a relationship between those things. So the data aren't independent. You would test that with a regular dependent t-test is what it ends up being. So, and so on. So you should practice these. Now, some of these you'll actually be asked to do a little bit more. Notice in this one that in step 4, I gave you the p-value. Now that's all I really give you. But with the p-value, you can pretty much do everything else. And the nice thing about this is that you don't have to worry about inputting data. All you have to do is do a lot of the rest of the stuff. Decide if reject or fail to reject. Set up your null and alternative hypothesis. There's no step 3. And then state your conclusion. State your conclusion in words. What else can you do from this one? I didn't hear all of what you said. Can you repeat it?
Yeah, when we test a hypothesis, sometimes like the confidence interval pops up.
Right.
Do you say that we should plug it in separately instead of using that one?
Sometimes, yeah. I think it's probably the safest thing to do is to create your confidence intervals separate from the output that you get in your hypothesis test. Now, the time that it'll actually work is when you have a hypothesis test of equal and not equal. When you have a one-sided test, like a right tail test or a left tail test, then your confidence interval is not going to match what you really want. So, If you want to keep all that straight in your head, then you can kind of get away with things in the right spot. But the safest thing to do, if you don't want to bother with this stuff, is create a confidence interval from a separate menu. Just go do it by hand. Now that's a great and leading question, because one of the questions that I asked on your test was to interpret this confidence interval in terms of words. But even more important than that, and I'm not sure why it's not letting me, here we go. More important than that is this question right here. So I gave you a confidence interval for the difference in two population means. So the difference in two population means has a confidence interval between -1.7 and 13.6. Given the above confidence interval, would you reject H0 or fail to reject H0 for the hypothesis below? And the hypothesis below is for two population means being equal. Well, how am I supposed to decide whether or not I reject or fail to reject based on the confidence interval? Well, it's whether or not this confidence interval contains a possibility of 0. That's what it boils down to. Because if mu1 equals mu2, so mu1 equals mu2, that's the same as mu1 minus mu2 equaling 0. So if 0 is part of your confidence interval, you shouldn't be rejecting H0, because your H0 is going to say, oh, these two are equal. That means the difference of them is 0. If your confidence interval doesn't contain zero for the difference of these things, then you should be rejecting H0, because you're saying this is not a possibility, meaning that's not a possibility. Comments on that one? Here's another one that, I kind of did part of it for you. So it may be the case that I can write this test so that you don't have to use your laptops at all. We'll see. I haven't written it this week yet, so I'll do that this weekend after the big game. And if I'm in a good mood, then it'll be an easy test. So if it's not, then buckle down and study hard. No, I'm kidding. Your fate is not tied to the results of a football game. Let's try another one. And let me see if I can't find. Actually, you know what? I should be able to just go back to the website and look at test 5. So we'll go back here. Let's take a look at exam 5. Not all the problems on exam 5 are things you're going to have to worry about. We haven't done analysis of variance yet, so you don't have to worry about that. But we did do population for 2 variances and standard deviation, so that's okay. This first one is an analysis of variance one. You can skip that. Second one, listed below are the student evaluations of male and female professors. Use a 5% significance level to test the claim that female professors and male professors have scores with the same variation. All right. First things first, how many populations are you working with? 2. What parameter are you testing? Remember, here are your choices, mu, sigma, and p. Which parameter are you testing? Sigma, absolutely. You're testing the variation, and that's what's described with sigma. Rats. I want to get rid of this one. Okay. Let's look at this next one. M&M plain candies are distributed with proportions in the table below. A handsome athletic mathematician bravely samples a huge bag of M&Ms and gets the observed column of data. Tests a claim that the color distribution is as claimed by Mars Incorporated. All right, well, is this going to be something from chapters 8 or 9? No. It's going to be stuff that we did today. It's going to be a goodness of fit test. So that would be up here. chi-square test of independence, chi-square goodness and fit test, right there. And so on. Let's see. If you have 3 samples or more, then that's going to be an analysis of variance. Don't worry about that stuff. We're not going to do that yet. What I'll do is I'll post on the announcement section which problems are ones that you should be able to look at. This one's a good one. So I give you a bunch of different possible values of R, which is the linear correlation coefficient, and ask you to determine which one matches with which. Where did it go? All right, it's not letting me zoom in. But let's start out with the easy one. Even without looking at the choices, can you tell me what the value of R is here? -1. And the value of R here, and the value of R here, what would that be? 0. Even though there's a relationship here, it's not a linear relationship, which is what R reflects. Now this would have to be something positive, this would have to be something negative, but overall you should be able to piece this together pretty quickly. Discuss the 5 things that can help us establish a causal relationship. These are the things I discussed in class. You should be able to fit a regression and interpret the slope in words. Difference between climate and weather. I think I've forecasted that you might need to know that. And what is the coefficient of determination that is R squared represented in words that a friend of yours can understand? All right. The coefficient of determination talks about the percentage of variation in Y that can be explained by knowing the value of X. So basically, it's a way to judge how good your regression equation is doing. All right, that's about all I got here. Any last minute comments or questions? Let me stop this and then get you out of here.